dangerous disease. So the next vitamin in the series is your biotin, oats, white mushrooms, spinach, wheat. They are all sources of biotin. Actually, you must have heard about the biotin. It was earlier called as an anti-egg white. Okay, anti-egg white injury factor. Okay, why I will explain in the later slides, but it is also called as a vitamin B7, or it is also called as a vitamin H, and is a sulfur containing B complex vitamin. It directly participate as a coenzyme in the carboxylation reaction. And again, there is a very interesting story. There was one scientist in 1927 who observed that rats fed huge quantity of raw eggs, developed a dermatitis and nervous manifestation. Also, there was a huge retardation in the growth of the rats that were fed with the huge quantity of, remember here, raw eggs. Okay, raw eggs. And then what happens, uh, this author or the researcher found that uh, feeding cooked eggs did not produce any of these symptoms on the rat. It was later shown that the egg white injury in the rat and other animal was due to the presence of anti-vitamin in the egg white. Suppose if you consume raw egg white albumin has an anti uh, vitamin. Okay, there is one vitamin, no, that one compound which will be antivitamin in egg white. So the egg white injury factor was identified by, like, that factor is a glycoprotein avidin. You must have heard about avidin, avidin. Okay, avidin and biotin was called as an anti-egg white injury factor. Therefore, biotin is also called as an anti-egg white injury factor, because the identified factor was that avidin and biotin. What is the chemistry of this biotin? So basically, biotin is a heterocyclic sulfur containing monocarboxylic acid. You see your favorite, this carboxylic. So this is a monocarboxylic acid containing heterocyclic sulfur containing. So the structure is formed by, you have, what is this? Where is this? Imidazole ring. Okay, this is your imidazole ring, and then you have this thiophene ring. This is thiophene ring, and this is imidazole ring, and you have this N. This is the site for binding, and this COOH, where it binds with the lysine in the enzyme. Okay, lysine in the enzyme. So this group. So these are the binding sites where. So this basically, biotin is a heterocyclic sulfur. You see this sulfur, sulfur containing monocarboxylic acid, and it is a fusion of imidazole and thiophene ring. So this is the thiophene ring, this is the imidazole, and there is a fusion of these two rings with the valeric acid chain. You see, this is valeric acid chain. So biotin is covalently bound to epsilon amino group of lysine to form a compound called as a cytine. Biocytine. So this biocytine may be regarded as a coenzyme of biotin. Okay, coenzyme of biotin. So it's a water soluble vitamin, and it functions as a coenzyme in many reactions such as carboxylation, transcarboxylation reaction, and there are two forms that occur naturally. One is free dibiotin form, and the other one is a biocytine form. As I mentioned, biotin is this by can form the biocytin. How? By covalently bound to epsilon amino group of lysine to form the biocytin in the enzyme. Okay, so this is the coenzyme form of the biotin. So biocytin functions as a coenzyme form and actually consists of biotinylated lysyl residue covalently incorporated in a protein chain of carboxylate. So you see, this is the biotin. There are two rings. Okay, and this one is a COH, which is a active binding site, and this is the biocytin. So the ring system of biotin can exist in 8 possible stereoisomers, only one of which, that is the D-biotin, is natural and biologically active form. Both free biotin and protein bound biocytin exhibit activity when consumed in the diet. Biotin is widely distributed in plant, animal product, and biotin deficiency is rare in normal humans. So you saw that this is a fusion of imidazole and this valeric uh, thiophene ring with a valeric side chain, and then biotin is covalently bound to epsilon amino group of lysine to form biocytin in the enzyme, and this may be regarded as a coenzyme. What is the stability? Biotin is very stable to heat, light, oxygen. Extremes of high or low pH can cause degradation, and they promote hydrolysis of amide bond of the biotin ring system, and therefore there is an oxidizing condition, such as there are many conditions in which food comes through the oxidization condition. For example, exposure to hydrogen peroxide, which can cause oxidization of sulfur to form biologically inactive biotin, sulfoxide or sulfone. Reaction of biotin ring carbonyl with amines also may occur if the product is rich in, amines. Losses of biotin during food processing and storage are documented, and this may be due to because of the chemical degradation, leaching of the biotin, and little degradation of biotin also occurs during low moisture storage, particularly in case of fortified cereal products. And overall, if you see, biotin is quite well retained in food, and the stability of biotin during storage of human milk is also examined, and it was observed that the biotin concentration of the milk sample did not change over 1 week at ambient temperature, whereas for 1 month when it was stored at 5 degrees Celsius, or when uh, at minus 20 degrees Celsius, the biotin was most stable, and over the period of 1.5 years. So the temperature of the storage for biotin makes a big difference. Okay, so there are again analytical methods, and as I explained in case of folate, here also the biotin can be measured or quantified by using microbiological assay, and lactobacillus plantarum is the bacteria, or by various ligand binding procedures which involves avidin as a binding protein. So there are several HPLC methods that could be used to quantify the this analysis of this biotin. Additionally, there are microbiological and ligand binding assays are there, but then uh, there are different forms of biotin, like whether it is a free biotin or enzyme like biocystin form. So this biocystin form cannot be determined unless it is first released. So one has to make sure that this biocystin is released from the protein by cleavage of peptide bond. So one has to perform first enzymatic hydrolysis or acidic hydrolysis, so that then biocystin is converted, like brought into its original form or released from the protein. So care should be taken while this hydrolysis by either enzyme or acid. It should not degrade a substantial proportion of biotin, because acid and obviously the enzyme would have some effect on the biotin. So the existence of nutritionally inactive biotin analogs such as bis norbiotin and biotin sulfoxide have been detected in human urine, and therefore they may complicate the analysis, and these such analogs may respond in avidin binding procedure and certain microbiological assay. The talking about the bioavailability of the biotin, there appears to be sufficient biotin in normal diets. so that incomplete bioavailability usually has little adverse in nutritional impact. So in addition to that, bacterial synthesis of biotin in the lower intestine also provide an additional source of partially available biotin for human. And but majority of biotin in many food exist as a protein bound biocysteine, and this is released by the enzyme called as a biotinidase in pancreatic juice and in the intestinal mucosa to convert this bio bound biocysteine form to free form. So but some absorption of biotinyl peptides also may occur. So totally by absorption of biotin is totally prevented by if you consume raw egg because of the protein biotin binding protein called as a avidin. So this avidin is a tetrameric glycoprotein that is present in the egg albumin, and that egg albumin glycoprotein has an ability to bind one biotin per unit. So you can imagine. So this protein basically binds very tightly and resists the digestion, or there is no avidin bound protein biotin is absorbed at all. Okay, so little or no avidin bound biotin is absorbed in the body. So chronic consumption of raw eggs or egg albumin, there are people I have seen who consume raw egg, at least there are people, yes, in the western country also I've seen, but in the India also people who consume raw eggs, so they will have this biotin impaired absorption, and they that can lead to deficiency of biotin. So small amount of iodine in the diet have no nutritional consequences. So there was a study how many eggs, like lot of eggs. So use of dietary iodine permits the experimental development of biotin deficiency, and cooking denatures iodine, eliminates its biotin binding properties. So cooked egg or omelette or cooked egg will be good. So what are the functions? As I mentioned before, biotin is a coenzyme and it acts in a very different carboxylase enzymes, several carboxylase enzymes that add carbon dioxide to various compounds. It is required for carbohydrate metabolism, protein, fat. It is needed in carboxylation of pyruvate to form oxaloacetate. It is needed for breakdown of threonine, leucine, methionine, isoleucine. It is needed for carboxylation of acetyl coenzyme A to form malonyl coenzyme A. So it can be then synthesized. So this is the same thing, like it is required in various reaction like citric acid or glucose to or oxaloacetate conversion. Here from pyruvate to acetyl coenzyme, biotin is required. So what are the sources of biotin? Can be found in whole grain, eggs, nuts, legumes, and also made by intestinal bacteria. So if you consume chicken liver, 3 ounces of chicken liver consumption can meet a very good, like around 45% of the intake can be met. And there are other sources also, like peanuts are very good source of biotin. So a daily intake of about 100 to 300 milligram is recommended for adult. Biotin is normally synthesized by the intestinal microflora in the human system. However, there is a deficiency of biotin observed rarely from eating raw eggs. So eggs contain that protein iodine which binds to the biotin, and thus it reduces the absorption. Um the if infants do not possesses the enzyme needed, like that is biotinidase, for the digestion to remove the biotin from the protein, can lead to also deficiency. But this is very very rare, one in 1,12,000 children. So this case is very very rare, and that symptom would be skin rash, hair loss, neurological disorder like convulsions or impaired growth. A deficiency symptom could be further anemia, loss of appetite, nausea, dermatitis, and biotin deficiency may also result into depression, hallucinations, muscle pain, dermatitis. Biotin deficiency is, although it is uncommon because this is well distributed and also supplied to intestinal bacteria. Okay, so basically high consumption of raw eggs only. So how many eggs? So there was one study in which 20 eggs per day they are needed to produce biotin, and no bird is going to consume 20 eggs in a day. Okay, so high consumption of raw eggs contain this glycoprotein avidin, which tightly binds with the biotin and blocks its absorption. An intake of 20 eggs per day needed to produce this biotin deficiency symptom. And consumption occasional raw egg will not, like just